Let us go ahead and solve systems of linear and quadratic equations algebraically. So that means using algebra. We're going to review linear quadratic systems, and then we're going to go ahead and look at the techniques for solving linear quadratic systems. So linear quadratic system is one in which one of the equations is linear and the other one is a quadratic. An example here, we can see this is a linear equation right here, y equal to 2x minus 3, and we have a quadratic, y equal to 3x squared plus 5x minus 7. Now here's how we're going to go about solving this linear quadratic systems. For the linear systems, we're going to rewrite in the form y equal to mx plus b, and for the quadratic equation, we're going to write in the form y equal to ax squared plus bx plus c. And then because we have y equal to in both equations, we're going to equate y equal to y, so mx plus b equal to ax squared plus bx plus c. The next thing we're going to do is group the common terms together, and then we're going to solve the resulting quadratic equation, get the value of x, and then substitute that back into one of the original equations we had in the system. I typically like to use the linear, but you can use the quadratic if you prefer. So let's go ahead and start working through some examples. So we want to solve y equal to x squared plus 3x minus 5, and then y equal to x plus 3. Now we already have these equations in the desired form, so what we're going to end up with is x squared plus 3x minus 5 is equal to x plus 3. Now we're going to group common terms, so we have x squared plus 2x minus 8 equal to 0. So we're going to factor this quadratic equation. So we have x plus 4, x minus 2 equal to 0. So x plus 4 equal to 0, which tells us that x equal to minus 4. We also have x minus 2 equal to 0, which tells us that x equal to 2. So I'm going to substitute these two values into y equal to x plus 3. So we have y equal to x plus 3. So x equal to negative 4, y equal to negative 4 plus 3, which is equal to negative 1. X equal to 2, y equal to 2 plus 3, which is equal to 5. So the solution to the system, so let's say solution, we have two solutions. We have negative 4, negative 1, and then we also have 2, 5. So this is the solution to the system. Let's take a stab at another example. So the first thing we're going to do is look at the forms, they're in the desired form. So we have x squared minus 4x plus 6 equal to x plus 2. So we're going to group common terms together. We have x squared minus 5x plus 4 equal to 0. So now we're going to solve this quadratic equation. We start by factoring that. So we have x minus 4, x minus 1. So x minus 4 equal to 0. So x equal to 4. We have x minus 1 equal to 0. Then we have x equal to 1. So now we're going to use y equal to x plus 2. So what that means is x equal to 4, y equal to 4 plus 2, which is equal to 6, x equal to 1, y equal to 1 plus 2, which is equal to 3. So for our solutions, we have 4, 6. We also have 1, 3. We have y equal to x squared minus 9x minus 18 and y equal to x plus 3. These equations are in the desired format, so we're just going to equate them. So we have x squared minus 9x minus 18 equal to x plus 3. So now we have, grouping common terms, x squared minus 10x minus 21 equal to 0. So here we're going to try to factor this, but before we factor it, let's look at the factors of 21, negative 21. We have 1 and 21. So negative 1 and 21. We have 1 and negative 21. We have 3 and negative 7, negative 7 and 3. So we have a situation here where we cannot directly factor this. So we're going to use a quadratic formula. So x equal to minus b plus or minus square root of b squared minus 4ac over 2a. So this is going to be minus of minus 10 plus or minus square root of b squared minus 10 squared minus 4 times 1 times negative 21 over 2 times 1. So this is going to give us 10 plus or minus square root of 100 plus 84 over 2. We have 10 plus or minus square root of 184 over 2, which gives us 10 plus or minus 2 square root of 46 over 2, which is going to give us 5 plus or minus square root of 46. So we have x equal to 5 plus the square root of 46. We also have x equal to 5 minus the square root of 46. Now we have told that y is x plus 3. So x equal to 5 plus square root of 46. Y equal to 5 plus square root of 46 plus 3, which is 8 plus square root of 46. X equal to 5 minus square root of 46. Y equal to 5 minus square root of 46 plus 3, which is 8 minus square root of 46. So solutions, we have 5 plus square root of 46, 8 plus square root of 46. We also have 5 minus square root of 46, 8 minus square root of 46. So this is how you would apply the algebraic method to solving a system of quadratic and linear equations.